All right, so I am showing 11 a.m. Central Time on my end, so we can go ahead and get started. I just wanted to start things off by welcoming everyone to our 2022 Plant Healthcare webinar series. And just before we begin with everything, wanted to let you all know, if you weren't already aware, that we recently changed our name from Rainbow Tree Care Scientific Advancements to Rainbow Ecoscience. And we did this to simplify our name and to better capture how we have evolved the way we serve and support companies, municipalities, and organizations just like yours. And to do this without losing some of the legacy of our company from the last 25 years when we began. We're really excited about this change, and you'll see this reflected in all areas of our company moving forward. So before we begin, I wanted to start off with a quick safety brief. One of our core values at Rainbow Ecoscience is safety. So before we begin, we always like to complete a quick safety brief to remind ourselves of some of the safety protocols. So for yourselves that are attending this webinar right now, please check your surroundings for any trip hazards such as cords or bags. And we have attendees from all over the country, so please be aware of any inclement weather that's occurring in your area. And if you are in your vehicle, please make sure that you're parked in a safe location so you can listen to and watch this safely. So, brief introduction to myself. My name is Eric Lindberg. I'm the lead technical advisor at Rainbow Ecoscience. I'm here to serve in a variety of different ways, such as training and education on PHC protocols, answering any sort of technical questions, providing some product and equipment support, and also doing a lot of hands-on field support and application training, while also specializing in creation of some EAB management plan development and invasive species plan development. Been with Rainbow for about 5 years, coming in March. Got a bachelor's degree in ecology and environmental biology from UW-Eau Claire, and have a master's in biology with an emphasis in forest ecology that I got from Texas Tech. That's a little background on myself, and just want to go over some quick housekeeping on this. So if you have any questions for this webinar, please type that into the Q&A portion of the box using your control panel, and we'll answer all questions that come in at the very end. So we are recording this webinar, and it will be available afterwards. And all of you that are attending will receive an email with a link to view it afterward. And finally, this webinar is worth 1 ISA CEU. If you didn't enter or don't remember if you entered your ISA certification and during registration, you can type that into the Q&A box right now, and we'll make sure that you get your CEU. Again, make sure that you use that Q&A box, not that chat box for that. And with that, it's my pleasure to introduce our speakers for today. And so first we have Dr. Rich Hauer. He is currently a professor of urban forestry at the University of Wisconsin-Stevens Point. He teaches courses in the urban forestry, tree care culture, and woody plants / dendrology. Rich has conducted research and professional practice in tree biology, urban forest management, emerald ash borer management, trees and construction, as well as ice storms. He received a BS in urban forestry and botany from the UW-Stevens Point, an MS in tree biology from the University of Illinois, and his PhD in urban and community forestry at the University of Minnesota. Additionally, we have Blake Thilmony, and she is the R&D project manager for Rainbow Ecoscience. And prior to her taking on her role in R&D, she was an emerald ash borer technician, insect care and plant healthcare crew member, and a vegetation management technician for Rainbow Service Company in Minneapolis. She has a bachelor's degree in Spanish and natural resource management with a minor in chemistry, and also has a master's degree in plant science, both from North Dakota State University. And so with that, I will go ahead and turn that over to you, Rich, and I'll let you do your presentation.
Well, thank you very much, Eric. And hopefully everyone can see my slides now. Looks good. All right. Hey, it's my pleasure. Thanks for inviting me, Eric and Patrick and Blake. My pleasure to present on some knowledge about tree injection systems. But before we get into that, certainly when we talk about plant health care, we think about the aspect of what are we doing? I like to use the phrase, is there something you're doing to the tree, or is there something you're doing for the tree? And really, we could think about preventing things from happening. We could cure things from happening. And when I think of those two things, if you prevent something, you kind of are working to maintain health. You implement something, you monitor. Curative type things, you see the problem and you're trying to restore the health of the plant perhaps, and then you monitor and you implement. Certainly, both of these kind of have parallels on the things that we'll be talking about next. However, I want to first kind of go down the pathway of what do we know actually about tree injection systems and how do they come to be what we have today. And for example, we could go back into the 12th century where there's evidence that people were working to infuse colors and smells into plants, in particular the flower itself. We could think about the 15th century. Now, there may have been work between the work in the 12th and the 15th, but this was some work from Leonardo da Vinci. And I think it's kind of fascinating where Leonardo da Vinci actually injected arsenic into apple trees to prevent theft. Now, this is not on any label to do this, and I don't think it's good practice, certainly, to put arsenic in apple trees to prevent the theft of them. But nonetheless, what the work that Da Vinci did kind of came up with some of the modern concepts of you drill a hole into a tree, in this case, a slanted hole, and you fill it with material, in this case, arsenic. Now, again, I would not recommend doing this. It's probably no label rates for arsenic application in trees today. But Leonardo da Vinci also has some pretty cool stuff that actually has tested, time. In this case, he came up with the concept that if you look at the biomechanics of a tree and you look at the cross-sectional area, the parent stem is equal to the branches that come off of there. And has this actually held the test of time? It actually has. For example, there's a study that was done about 6 years ago where they looked at the work of Leonardo da Vinci and they found out his model certainly does have the test of time. One little difference though, trees that actually droop downward the branches where they may get adaptive growth, that actually adds a little to the surface area of the branches that come off the parent stem, but nonetheless, huge contribution from Leonardo da Vinci in this one, but not the arsenic. Now, you could actually find this book from 1720, New Improvements of Planting and Gardening. It's a Google book. There's other places that have this in the public domain, but it's quite fascinating. Where here's some work of actually using it for insect control. In this case, injected into the tree was what was called quicksilver, which is mercury. And it's quite fascinating if you read the words here of, inform from fear fawn of the honor that to prevent the insults of theft or other insects, he has known to practice to bore a hole with a small gimlet, flopping downwards through the bark, for as to reach the wood of the tree and pouring in some quicksilver, about a ½ ounce or more, according to the belief of a tree, that basically putting it in, the insects then harboring upon it will be destroyed. Now, they actually had evidence that mercury did kill the insects, especially on the branches they injected it into. And there is some translocation that insects on neighboring branches a few days later did actually die. So apparently mercury does work, but again, there's no label rates for using mercury, and plus mercury poisoning in the environment is not a good thing. So don't do that. Now, it wasn't until really the 19th and 20th century when science was really starting to be involved with looking at tree injection systems. And if you look at this picture here, there's a lot of different authors, a lot of different things that were being done. But the fascinating part is a lot of the things that were kind of being experimented with on nutrients or insecticides, for example, being put into a tree, is they're either using some sort of gravity system and they're using the transpirational stream to pull it into a tree, or using some sort of pressurized system. And for example, here, this is just an application of a grease gun. And so they're using the application of pushing into that plunger to put some pressure to help move chemicals into the tree beyond just the transpirational stream. Now, in the 1930s, there was really a seminal publication that came out by Dr. Roach, where he looked at the plant injection as a physiological method, which is kind of fascinating if you look into this, that it's a quite comprehensive compendium at the time. It's over 70 pages in size. It's actually an 8.5 by 11-inch sheet of paper. If you fold it in half, you've got 2 pages per sheet, but nonetheless, you have quite a substantial publication. And there is specifically 4 pages that were dedicated just to injection into trees. A lot of it, though, at that time was known of putting things into leaves, for example, or twigs or branches. Now, I think actually looking at increment cores really sets the tone for some of the things we'll be talking about here today. That, the evidence that if you drill into a tree, in this case, to extract a piece of wood using a boring tool, in this case, the wood is about 1/4 inch in width. The boring instrument itself is much larger. That, modern day things we know about discoloration, they're showing of, in this case, putting a hole into a tree. And a lot of this work from the 1940s, if you read early work from Shigo, he gives credit to this early work about discoloration in tree stems, whether it's a cross-sectional, in the case here of basswoods, seem to be better compartmentalizers along with sugar maple than birches. And then you could also look longitudinally. And I think you have to also think about, you drill a hole in the tree, or in the case of extracting a piece of wood for an increment core, is there something you should do to it? And they found, actually putting a piece of wood, a wood doll, for example, into the hole to plug it, it makes sense maybe, but what they found, plugging had no effect. And in some cases, what they found, there's a disadvantage. So the practice back then was you put a piece of wood, you'd pound it in with a hammer. And so they found that if you didn't get the wood doll close enough into the tree, there was a slowing of the cambial closure. But if you hammered too much to actually get this right to the cambial layer, the hammer itself would damage cambium. So don't do that. So the implications here is plugging a tree with the wood doll, in this case, to fill an open hole, really doesn't have any merits. And we could look further in the literature. It's quite fascinating, by the way. I spent this past week and actually just digging into some of this literature. Is quite fascinating. And certainly species have different ways to compartmentalize. We'll talk with ash later today here. And nonetheless, ash is a really good compartmentalizer. Things like hackberry, for example, in this case, it's cousin sugarberry, is a much poor compartmentalizer of damage. And also some more work on just wood dolls. In this case, wood doll impregnated with creosote. The idea here is to prevent fungi. And actually what they found was you're worse off. You got way more cambial dieback by putting something into the tree. So that's another part of the theme here today we'll be talking about. The other aspect I just have to end with here on increment cores, because that's not really what the talk is here about today, but it's really about putting a wound into a tree. It's a nice thing, is a really comprehensive study, and there's others out there that have found there's really no mortality effect of the size wounds we're putting into a tree and the number of them. And so at the end of the day, you're not going to kill a tree, but certainly there is an artifact of the wound and how the tree responds to it that we can see with discoloration. And certainly that's a side effect that, yeah, we'll discuss here today. Now, let's think about tree injection systems in a more modern context. And the 1930s, for example, or the 40s, and serially spray trees. And now, one of the unfortunate side effects is just it's in the ambient environment. And it could be a really benign pesticide, for example, but still just the perception of you spraying something into a tree, what is it? And you could probably hear really interesting stories of gypsy moth spray programs where the planes come in and spray BT. It really has no residual effect on human populations where it does for lepidopterans, but nonetheless, just the perception of an aircraft coming in and spraying this coating of materials, unless you inform the public, and I used to work for the Minnesota Department of Ag, where we had informed the public ahead of these spray programs just to, let people know what we're doing, and don't worry about it. But early injections in the 1960s, J.J. Mage company, where they came up with this encapsulated device to inject into a tree. And this is some work in the city of Milwaukee. So they're actually an early adopter to see if this had any impact on the Dutch elm disease spread in the city. And it was quite intensive. Now this is perhaps a kind of a photo op picture here, but they tried it in thousands of trees. In the end of the day, actually, it had no effect on Dutch elm disease. Now, did it kill insects? Probably. Did it prevent the disease spread? No. And we'll talk a little bit about this here today, but just from an application of how it relates to putting things into trees. Now we can look at work from Eugene Heimlich, and he looked at pressure. And this is really interesting. He was ejecting up to 400 PSI into trees, and he found no damage, in this case, American elm. I think one part that's kind of interesting here, because pressure can have an impact, was he used a device. It was a wood leg screw that they adopted to actually allowed a harness system to be put into the tree, and they had a huge compressor system hooked on, and they're putting 400 psi. I think maybe what was happening was this device was maybe far enough into the wood. It was quite laborious, first of all, just to put all these plugs into the tree. It wasn't pound them in, it was literally get the wrench out. And if you ever put leg screws into wood, it could take some time here. But regardless, huge psi. Now, some of the other more modern things of looking at PSI and some of the systems we have, that if you have a couple hundred PSI, for example, some work from England with Mayhead, all the species they looked at, in his case, it was 7, they had serious bark damage. Or in the case of Kevin Smith, some work from the 2000s where they found 300 to 600 PSI did lead to bark cracking. Our more modern systems, we use a much lower pressure system, but yeah, pressure does matter, especially perhaps where you also have your instruments. So that's something, or your tool, that's something that's pretty important to keep into context. Now, I'd be remiss without bringing up Mark Stennis. Now, I miss Mark. He passed away a few years ago, just a dear. He would liven up a room with just his sense of humor and his smiles. But in the 1970s, Mark coming up with the idea of how to get, in this case, Arbortect into a tree very effectively. And so you could have pretty good control of Dutch elm disease in the tree that was treated. And basically what Mark found was the lower in the tree you could go, the better. And more so of spatially putting around the tree, even better yet. And even more importantly, if you had it in this area that you could call the trunk flare, I like to use the term the root stem transition zone, because that's really what the tissue you have there. Along with using some pressure, you can get enough chemical to treat the tree, and it does really well. But what they certainly knew, and it's true to this day, that sanitation in the case here, so it's just not one thing, it's plant healthcare using many different types of ways to actually control the pest at hand. But certainly the application of using chemistry into an elm tree to get really good protection certainly did occur, and Mark certainly was one of these pioneers that we're indebted to. Now, in the case of sanitation, if you know nothing about it, and I hope that's not the case, the more you do, the better. And so that's really the key. Following up with chemical treatments, if you really want to protect a tree, definitely that works. And if you don't, you could look at Milwaukee. They didn't have the science, unfortunately, and they lost pretty much all their elms by the time the science came out in the 1970s. And this was a study that we actually have published looking at the tree canopy change over time in Milwaukee, and if we could have done something about Dutch elm disease. And basically what we found out is Milwaukee lost most all their trees, and there's really nothing they could have done. But if Dutch elm disease came at a much later date, they could use the science like the places like Minneapolis or Winnipeg have, where they have some substantial elm population still because of sanitation, plus also some trees on private properties and public for that matter are being treated. Now, summary of all this work up until basically the 1970s. And Kevin Smith did a really good job. It's a paper you could get from the Journal of Arboriculture. Just Google wounding compartmentalization and treatment trade-off. You'll get this, but a summary of this. And it's true, you look at the BMPs that Blake will talk about later this morning, is a clean edged hole as shallow and narrow as possible is important, and also as few as possible. The fewer the number of wounds you can put in the tree, the better. The other aspect, keep holes as low as possible, and certainly put them on actually that root zone transition. This was evidence from the 1970s, and it's evidence to this day. Also going around the circumference. This is like we're reading the ISA BMP for tree injection right now, and this is stuff from the 1970s. Or looking at previous wounds. If you're going to retreat a tree, look at previous wounds. Look to see how they're actually responding. Are they closing over? Do you have weeping? Is there something about the hole itself that suggests the tree is in low vigor? And so maybe another therapeutic treatment perhaps just isn't in the best interest of the tree or the client that you're working with, for example. And the last part of evidence here, advice that it gave was any treatment you give could have a lasting impact. And so really, unfortunately, some of the only ways we can see the damage that occurred with injection is certainly with dissections later on. And you might not be able to visually see the damage. Now, we do have some modern tools that we could use like resistographs or perhaps a sonic tomography, where we could certainly get some sense of what's happening inside a tree. Certainly encourage you to learn those devices if you've never been able to use them. But regardless, really good advice that was from the 1970s that Kevin was just pointing out in his paper in the late 1980s. Now, let's get into some work that we've been doing here at the University of Wisconsin Stevens Point, along with some cooperators throughout the Midwest. And really, I like to say, what's the worst that could happen? Now, my PhD advisor, Gary Johnson, this is a phrase he uses all the time. It just kind of, I think, just systematically kind of moved to me, but really, you're managing something or you're not managing. If you don't manage ash population, for example, they're going to die. And so, yeah, you may have an artifact of a wound that does cause some internal things, but if you don't treat the tree, the worst that could happen is the tree's going to die. And if you know and I hope 100% of you know that emerald ash borer, it just operates freaky fast, it's freaky bad, and it doesn't matter what type of land use. If it's a residential property, a street tree on municipal property, in a utility corridor, untreated ash will die. And so there's outcomes of the decision we make. And I like to think of in the case of maybe a sustainability context. And so we could look at this tree being treated for prevention of emerald ash borer. And you could really think in context of what's the cost, the economics of it, what's the societal interest or concerns, maybe the environmental impacts of what we're doing. And so the social decision, including people in the decision making. Now, if it's private property, you're working with a landowner that has a decision that they want to do something or not. If you're working in municipal forestry, you're really making a decision of what do your constituents want or not. And there's examples of cities across the United States where they've decided socially we don't want pesticides. And there are the other cities that have said, yeah, actually pesticides are used for emerald ash borer treatment, certainly are socially acceptable. And regardless though, excellent publication. If you've never seen this one, it's the third edition is out on insect options for protecting ash. And it talks about some of these social potential impacts of pesticides. You can look at the ecology side and the loss of ash populations. And this is some work that we did with the loss of elm populations, that there's an environmental loss of the loss of trees. And interesting, in the city of Milwaukee, we found that just the stormwater savings alone would pay for their, in this case, their Dutch elm disease management program. And they got all these other things. Air pollution, for example, energy savings and cooling of buildings. But what we found was also with looking and modeling ash tree populations, the same thing really comes out to play here. Now, there's some cool work that we did that we published, and I'm pretty proud of this work. That I worked with some undergrad students that we found out economically, it just makes sense to treat trees relative to doing other things. And economically, if you look at the value of money over time and you look at all the benefit minus the cost, treating trees makes sense financially relative to not doing it or just preemptively removing things. You're actually better off if you don't have emerald ash borer, but if you have it, the cost of treatment is so minimal relative to the value of the trees. Now, this is Milwaukee, but we found this is the same case of other places that we've modeled. And you can look at the impact of municipal budgets. The only reason I'm showing this is it really shows that as soon as you find emerald ash borer, you've got this lag period that you need to really decide what you want to do. Because if you don't, emerald ash borer is going to kill trees. It costs a lot of money. You really want to bring down this peak event, to minimize, the cost in any one year. Unfortunately, over time, it does kind of levelize itself. And it also kind of fits the mortality curve that Dan Herms you really popularized here. If you look at the emerald ash population of the borer, it builds up, it becomes exponential, and then pretty soon all your ash are dead if you do nothing. And this is the outcome. So how can we prevent these things happening? Well, here's one study I want to talk about. So I always think about the long game, the end game. And so we've got a study, I call it my retirement study. It's a 20-year program. We're in year 6 now. By the time this thing is done, I'll be around 70 or so. I think maybe it's time to retire by then. But nonetheless, we are treating all our ash on campus. But in the meantime, we're modeling the growth of trees that have been planted in areas where they're near ash. So the idea is 20 years down the road is what do we have from canopy of this relative to the canopy of the trees that we're replacing? And so, this is kind of fun, exciting stuff for me. Now, in the case here, we're trying different things like using soil injections with imidacloprid. Or now we're not applying this one, but this is another. You could use a soil drench method. We're using a systemic basal spray with dinotefrin. We're also using emamectabenzoate that we're injecting into a tree. And the results that we have doesn't surprise me because if we would have done nothing on our campus, this is what we'd expect. So the control trees we have in here relative to the treated trees are dying. Okay, that doesn't surprise me because this really replicates what has been shown back in actually till about 20 years ago. Some of this evidence first, or excuse me, 10 years ago, some of this evidence first started coming out that treated trees, the chemistries we have work really well. Now, here's one thing that is a little new is we're testing the difference between a 2-year cycle and a 3-year cycle of emamectin. And basically we find no statistical difference. And if you look at the bar graphs here, they look really similar. And this is just a condition rating. We're looking at a tree and looking at the root system, the stems, the branches, the twigs, and the foliage. So doing an overall 100% assessment of a tree on a scale of 0 dead to 100%, there's nothing wrong with the tree that we can see from an external perspective. And, they look pretty similar. Now, maybe you're wondering, why are the emamectins actually a little bit lower? We are actually using trees that are smaller in diameter. Anything 16 inches or below were treated with dinotefuran or imidacloprid. Anything over 16 inches were stem injected. And so these are bigger trees, but the other aspect, these bigger trees had a little more incidence of anthracnose. And for example, year 2019, and they've since kind of anthracnose not as much. So they're kind of at the same context now as these other chemistries, but just put a little context of the experiment. We also looked at things like crown thinning. And so this is something you should also do as just part of your routine practice when you're evaluating a plant, whether you should treat it with any type of plant health care or not. In this case, it's mean crown thinning. So it's using the Schmittli method. If you're familiar with that, you're looking at the tree and basically the transparency of lack of foliage. And so here, if you have 100% thinning, it means you have a dead tree. Okay, if you have 0% thinning, you really are, you look through the tree and you're not really seeing any transparency through it. So again, looking at these different approaches, whether they're basal bark sprays or soil injected or injecting in the root stem transition zone, is really, we see no difference relative to the controls, which are dying. And we see this with this mortality slide. Now, really, we had no mortality from emerald ash borer with any of the treatments that we're using. The control trees are dying from emerald ash borer, and we did have a windstorm. And I've always wondered, should I actually take these few specimens out, for example, the 2-year emamectin benzoate? And actually I've decided to leave these trees in, because this is really also, if you're thinking about managing populations, there's more than just the pest killing trees. So that's why we opted to leave these mortality specimens in here, that they're not emerald ash borer, they're from windstorms. And ironically enough, it was no more than a day after we treated some of our trees that a microburst came into town and it knocked over a couple of our control trees. And now, what if the control trees were knocked, or the trees were knocked down before we would have treated? I probably would not have included them, but just a little backstory on this I find kind of fascinating personally. Now, here's a study that we just completed from last summer, and we're really kind of curious about a couple terms here: a sealed system versus an open system. So a sealed system is something you put in. This is just an arbor plug, by the way, and this is just a hole that's drilled with nothing that's put in there, okay? And we're really curious, does this having any difference or impact on the wounds that we externally can observe? So external wounds that we're observing, is there a difference between these two systems, was the question we had at hand. We have a population of about 365 trees that we studied. It was in 4 locations in the Midwest. They're all in the same climate. One study site was the Chicago area, specifically Naperville. Another's Milwaukee, along with the city of Wauwatosa that joins it. The city of Minneapolis, and all the trees were in Minneapolis in this case, and then Sioux Falls, South Dakota, all within Sioux Falls. All the trees were street trees, and there's a few other dynamics behind this that I won't get into, but it was a population of 4 different locations throughout the Midwest. And what we found, if we look at just, can you explain a wound on the external part of a tree stem? And we found certainly trunk diameter. The bigger the tree, the more wounds. It makes sense. Bigger trees are older trees, and they may have wounds from the treatment that we're testing here, or they may have wounds for other things. So yes, the bigger the tree, the more likely to have a wound on the stem. And we're defining stem here from 4.5 feet down to the soil level. We also found City of Milwaukee had greater wounds on their trees. Why? Well, part of it is probably because they're treating trees longer. They've been treating trees in Milwaukee for 4 to 5 cycles now. Okay, and so more times of treatment relative to Sioux Falls. Many of the trees in our study there had only been treated 1 time, and so that's the backstory of why Milwaukee became significant in this case. We did find a significant effect with treatment system. For example, the sealed system with the plug, it had 7 greater times odds of a wound being observed on a tree. All right. We also looked at things like mean wound area. And so if you had wounds on the tree, what was the mean wound area on a tree? And how we actually got at this, we used a plastic template. And we put a 1 centimeter grid. So it was tacked onto the tree, and then we'd count the 1 centimeter sections, and then we'd sum those up to get mean wound area. Little side story behind this though, the year before I threw out all my transparencies because I figured I'd never use these again for anything in life, because we used to use them to make a transparency, put it in the laser jet printer, and then we'd have an overhead to lecture with. Yeah, who's going to lecture on an overhead anymore? So I threw them all out, and then this experiment came, so I had to go to Staples and spend like $1.75 to get each one of these transparencies made. Oh well, $20 later, I'm over it now. But what did we find out with mean wound area? Was we found actually there was a 4x greater wound area with the sealed systems. Okay. Now let's look at wound on a tree. So was there a wound present or not? And what we found, kind of a similar finding. There was a 4 times greater chance of just having a wound on a tree with those in a sealed system. So here's the open system. 11.6% was the mean average we got of the trees. And we had about 47.4% of the trees with a sealed system having wound. Okay, so is there more to this backstory than we found out trees with an open type of system for introducing, in this case, emamectin benzoate into a tree, had fewer wounds and they're smaller than relative to a sealed system? Well, actually, we found out was following manufacturer's recommendations matters. And so we had, as part of the study, could we explain the reason for a wound on a tree? And this came out when we initially got together as a research team. We picked Madison, Wisconsin last May. We got together first to calibrate kind of our methodology, and then to kind of see, are we collecting everything we needed? And this thing came out. We really need to look at, was the treatment properly done? And what we found, for example, with the sealed system, our observations were about 3/4 of the times that we saw a wound, we could observe it that it was related to improper treatment relative to the manufacturer's recommendations for that system. So truly following recommendations from the manufacturer is really important. That's a huge part of, I think, the wounding results with our study here. But the downside of this was it looks like practitioners in these 4 locations are having a challenge following manufacturers' recommendations. Maybe that's a training situation. Maybe it's more challenging to really apply that technique. Don't know. Those are all really good research questions that need to be followed up on. But regardless, these are results we found from this past year. Now, this is a publication. Blake will talk about this a little bit here in a few minutes, that really following manufacturers' recommendations is super important. And so, for example, with the sealed system here, using a plug, is the correct depth is vital. And so if it's set too deep or if it's set too shallow, those are all artifacts that the manufacturer would say could lead to more instances of external problems that you'd observe on a tree. So for example, closure or perhaps bark cracking. So if we look at the size of wound, the size of wound certainly matters. And so, for example, this was some work done at Michigan State University where they looked at just the size of a wound relative to closure. Smaller wound probably doesn't surprise you, closes quicker. And so a closed wound is good because you don't have entry of things externally getting into that plant that could facilitate maybe decay later on or some other, some dysfunction within the tree. And those that were drilled that had an open system relative to having a sealed system closed sooner than with the sealed system. And now this one, it's kind of interesting. It's a system that comes out of France, actually Italy, and they use basically a edged blade to create a longitudinal slice that they then use a device to inject trees. The people that came up with this say it's phenomenal. The evidence from just a wounding closure perspective, what they found in Michigan, yeah, perhaps it works, but not as well as they suggest perhaps in Italy. Now, just on the home stretch here, I'd be remiss without looking at some of the literature, especially where we have a controlled situation. The work I just presented from Milwaukee and Chicago area and Minneapolis and Sioux Falls was an observational study done in the field, looking at comparing 2 systems, a sealed system versus an open system, where we don't know who the practitioners were. We don't know how they did the work. We don't know the type of chemical they put in, although we have some evidence in that it was pretty much emamectin benzoate. So there's a lot of unknowns that in a control study you can pull out of it. But nonetheless, we had all this background noise from just a non-controlled study where we're testing 2 different systems that we're still able to detect some significant difference between systems. The case here, controlled study, it's the work of Joe DeCola, really cool paper from Arboriculture Urban Forestry that they found using a sealed system after 2 years, 76% of the trees were closed over. But they found tree health is important. So unhealthy trees maybe be candidates of, if you're treating them, maybe they're not the best trees to treat. So tree health is an important aspect, regardless of what plant health care technique you use. Another aspect is, this is just longitudinal, study, and this with ash from Joe's paper, and showing the longitudinal spread of discoloration, and ash compartmentalized pretty well. So that's a good thing to know. Some plant species don't compartmentalize very well. And then you can look at a cross-sectional. This is some work from Sarah Tanis and Deb McCullough from Michigan. And they found that in the case of using a sealed system, they were able to observe about 5% bark cracking. Now, they didn't make a conclusion about whether it was following manufacturer's recommendations or not. I'd suspect, as a scientist, knowing Dr. McCullough, she'd be really good of, if this is what the manufacturer says, this is how we apply that technique. Okay, and 85% closed over, in this case, a few years time period. And then the last paper, and then I'll turn it over to Blake, is it's really important, I think, to understand if we're injecting trees, what's the longevity? How long can you do this? I remember Mark Stennis telling me he had some thoughts that maybe after 20 years, American elm, yeah, maybe it's going to be challenging for all the wounds that were put into a tree every 3 years, for example. So after 6 treatments in this case, maybe 7, maybe you have so many wounds that this tree and all the compartmentalization inside, maybe it's just not possible to do anymore. Now, this is the only paper I know long-term where Dr. Brzee actually investigated this. This was with American elm. And these were trees that had been treated on a long time period. And they found no difference in decay between those under an injection program long-term versus those not injected. And so just a little evidence here. They use the resistograph to detect potential. Really, are they detecting decay, or are they detecting actually the amount of force that goes through a tree? You'd probably argue with the resistograph the latter, but regardless of the results here, truly they found no difference between the trees that have been treated long-term versus those that had not. So I'll turn it over to Blake here, and really I have to end with this, that whatever you do from a plant healthcare perspective, active management is better than no management. And really thinking about the side effects is important. Making observations of what you're doing to learn from that. Following a manufacturer's recommendations, super, super important. And having said that, I'm going to stop sharing and turn over to Blake.
Thanks, Rich. That was fantastic. Give me just a moment here, folks, while I get my share screen set up.
I'm going to add, we'll take questions and answers after Blake's presentation.
Thanks for pointing that out. Yes. Okay, so, oops. All right, have we got it set up so you can all see this? Move this.
Looks good, Blake.
Great. So I'm going to start off here kind of where Rich left off with his timeline around the macro injections and the work that Mark Stennis had done in really introducing injections as a standard in the tree care industry. So Rainbow is unique compared to most other tree care companies in that we actually started out as an inject care company. We were only injecting elm trees. So we were initially known as Rainbow Elm Care, have since changed names over into Rainbow Tree Care, and have been injecting trees ever since. Today, our company has about 8,000 elms, 15,000 ash, and 4,000 oak under our inject care programs. And we've got quite a robust team that comes in each summer to do this work. So with that, we've got a lot of training and experience that we've got under our belt that I'm hoping to share with you all today. So starting with our injections, in 76, really it put us at the forefront of research and injection technology. And really we were injecting trees before it was cool to inject trees. So what we did, we worked within the different chemistries and systems out there to find one that was effective, but then also kind of hone in on that effective chemistry and find a treatment practice and method that we could use to protect trees in the Twin Cities area, and then kind of expanded to train others to be able to use that same system and help them protect trees in their areas as well. With all of this research happening, it was really in the 80s that this kind of kicked off for the industry. Shigo made some great advancements in understanding of tree anatomy and structures, as well as sharing with us his model for compartmentalization of decay in trees, which kind of paved the way for tree injection to become standardized and accepted across the industry. In the 90s, this became more and more prevalent and then began to expand into oak wilt and micro injections of nutrients. And then when the invasive species like emerald ash borer and hemlock woolly adelgid hit, that's really when micro injection of pesticides became the standard and really drove a lot of research around that area. So us as a company, we expanded with it, with the rest of the research, and we adopted microinjection techniques as well. We started off with the same as everyone else, what was available at the time, which was a microinjection system, which involved these arbor plugs or these sealed wounds. And so like Rich touched on a little bit, these plastic plugs are inserted to the tree and keep the treatment in the tree. But what we observed anecdotally was that we were having potential damages in wounding in these trees that were treated. On top of that, we would spend time training our technicians, but there was a disconnect between the training and then being able to properly set those plugs while they were actually in the field and trying to meet production demands. So we kind of went back and we're trying to see what could we do to innovate on these tree injection systems, how can we improve them, and we came out with something in 2012 called the Q-Connect tree injection system, which was kind of our improved version of what was available at the time. The biggest improvement in my eyes was going to this plugless tip here. So this tip was actually adapted based off of the APHIS recommendations and the work and research that APHIS had done to really get the proper shape to inject into that xylem layer. And on top of that, we had this ergonomic design where you can just grab those handles really nicely, these easy closed ball valves, and just a really quick push to connect fittings so that you can easily adjust each kit on each tree for you. Now, in the last couple of years, we've made a few improvements on this system, namely increasing the thread count on the bottles so that we could decrease any cross-threading or issues there, adding this fill point to, again, decrease the chances that you have to take that top off the bottle, and then making a few minor changes on the color and the carrying case and whatnot. But apart from that, this system has pretty much remained the same since we came out with it because it's reliable, it works, and it's easy to use and easy to train in the field. Then on top of that, you don't need a bunch of extra specialized equipment to run it either. You bring your drill, and then it requires just a standard Schrader valve bike pump to pressurize it. So again, it's easy to use, easy to find the equipment to do it. Next, we improved on this technology, and this will be released this spring. So I'm really, really excited to share it with all of you. But it will be called the Quantum, and it is the powered tree injector. The idea behind this is that it's going to be really fast and easy to use. It's intuitive and accurate, and is something you can kind of take as a one-stop shop to go do any tree injections out there. So getting into this a little bit, I won't jump into all of these little details here, but the ones I want to pinpoint and focus on are this tank, having this removable tank. One, it holds a whole quart of product, so over 1,000 mils. So you don't have to measure out product in between each tree throughout your day. And then it will come with multiple tanks, so you can easily take those tanks out and replace them with a different product or use it to clean your system out. A couple other points on this, it will have a pump that's going to work with the pressure in the trees. So with one thing, with some of all of these improvements that have been made throughout the years, there's been a vast improvement in the chemistry of the products being used. And as Rich was talking about, the higher pressures causing more bark separation and damage, we found that as these chemistries have been improved, we're able to use lower pressures and still get the same efficacy and uptake of these products. So this device is designed so that it doesn't blow off the bark and it doesn't force anything into the tree, but kind of works with the tree's pressure pushing back so that it's not not causing damage and unnecessary wounding. And then again, as always, we will have our plugless tees to be used with this. It's got a really easy to use interface and design there. And then it's just going to be used with a standard rechargeable 12-volt battery. So it should be something that can fit into your current equipment, and you don't have to get a bunch of extra stuff to be able to go out and inject trees with this device. So those have been kind of the more recent advancements in our technology for injecting trees. But what I'm going to touch on next is the best management practice guide that ISA came out with in 2015. And I think this is really important because regardless of whichever system you're using, as Rich touched on, the application is probably the most important part of it to make sure that you're getting fast distribution, that you're getting effective uptake, and that it's being done timely without causing any unnecessary wounding. So this was a couple of different industry collaborators were brought in on this. One of our own, Sean Bernick, was involved and was able to really bring back that knowledge he gleaned from this and contribute to this. So this has been a big part of us being involved in the training, and we involved this in a lot of our training for our one-on-one technical support with our clients. And it really highlights applying into that root flare zone, or as Rich would call it, the root zone transition, and then as well as the proper drilling. So we'll dig into that here, some more details and some photos. So why root flares? One, root flares, we found that they've got a greater ability to compartmentalize those wounds compared to that upwards trunk tissue. Next, they have slightly more active xylem, so that xylem is going to be, that's part of what allows it to be able to compartmentalize quicker, but it also means it can take up that product quicker as well. The next thing when you think about tree anatomy is kind of, as you go up into the trunk, you run into these rays in the tree that are going to be blocking radial movement sideways. So we have less of those rays down in that root flare zone, and that product is better able to distribute sideways, side to side, which then means that you get better distribution throughout the entire canopy. Because if you're injecting just into those trunk zones and it's just going straight up in little lines, it ends up leaving kind of empty spots in your canopy. Whereas if you inject lower, that product distributes side to side and then it gets all taken up. You get better distribution. With this photo, you can kind of see a little bit more how that xylem tissue down at the root flare is a little bit wider, and as it goes up, it narrows as well. So that contributes again to the root flare applications. And then drill depth. Drill depth is going to be really important. As Rich said, you don't want to drill in too deep. You don't want to cause unnecessary wounding, but also species is going to be really determining how far you're going to drill in, as well as the thickness of the bark plates or that bark ridge on there. So you want to get past that bark and down into the xylem. On average, we say about 1 inch, but again, that can really depend. Another important thing about the drilling is keeping that at a 90-degree angle. So kind of see here on this photo, you keep this T 90 degrees from the root flare. So if you're injecting down here, your T is going to be angled a little bit more this way. And that really helps you get a nice sharp cut into the xylem, along with using a high helix drill bit. And so these drill bits are going to cut going both as they're spinning in and as it's coming back out, which will help avoid us any unnecessary cauterization of the wounds. Another little tip I'd give is when you're getting ready to drill into the tree, don't set the bit onto the trunk before you press engage the trigger. Pull that bit off of the trunk a little bit, engage the trigger, and then make a nice clean cut in and straight out. Don't rock that bit back and forth or wiggle it. and try not to keep that drill bit in the hole and keep spinning it, because that'll cause one, further unnecessary wounding, but also can cause that hole to widen a little bit, giving you less efficacy when you're actually injecting that product in. A couple of things that are going to affect your uptake. Again, different species in general, ring porous are going to inject a lot faster than a diffuse porous tree. And soil moisture is going to be really important. So if the tree is not actively transpiring or moving nutrients, you're not going to have that product being taken up. So that'll occur both in droughty conditions as well as really waterlogged soils. So you have to keep soil moisture in mind. Best practice, if you've got really dry conditions, we suggest properly irrigating the soil prior to injection. It does not hurt to go ahead and irrigate again after if the soil is dry enough. And then last, Rich touched on this as well, but tree health is going to be really important. So if a tree is stressed, it's growing thinner layers of new xylem tissue, which means your uptake time is going to be a lot slower, but it also means that the compartmentalization is going to be slower as well. So definitely something to keep in mind there when you're out there injecting trees. And just a few conclusions: proper application techniques, regardless of the system you're using, are going to be incredibly important for trunk injections without causing significant wounding. Always follow the tree injection BMPs. Oh, and one thing I forgot to mention that has just recently been revised. I don't believe the newest version is out yet, but should be something you can look for coming soon. And then, as always, we at Rainbow here are more than happy to sit down with you and conduct any in-person or virtual training in the field. We'd love to walk you through the systems and any of our tips and tricks to help you improve your tree injection practices. So with that, I will open it up back to Eric for the Q&A.
Great. Thank you, Blake, for that. Let me just pull this up quick. Let me see the chat. Okay, so the first question that we have is, are there any pesticides for trunk injection registered to use in Canada? As far as I know, only Triazin and Imajet are the only two products.
Well, I guess I can speak to that. I am not aware of any other products. I don't know, Eric or Rich, if you've got any other input. Currently, I'm only aware of those two as well.
Yeah, I don't keep up with Canadian registrations on a daily basis, but that's also my understanding is those two products are the only ones. And
yep, and the only other one as well, I believe Arbitect is
yes,
available for use in Canada, but in terms of insecticide injectables, I believe those are the only two. Okay. Lawrence had asked, should we remove the plugs after injection?
well, it's Rich. Great question. I would say, based on the evidence I'd come from this perspective. Leaving a plug in the tree doesn't help the tree. Now, the argument would be is you have a barrier to external things getting into the tree that, for example, decaying organisms. So that'd be something I'd want to actually look at. The other is it causing some harm to the tree? And there's some evidence from just our work that if you don't follow manufacturers' recommendations, that could be an issue. Looking at some of the things I presented on putting plugs in trees, for example, with increment cores, they found that, yeah, if you do this improperly, you can cause greater damage, but they didn't find any evidence that just a plug itself was going to be beneficial. So I think, to answer it from a scientific basis, I don't know of any studies that have investigated removing a sealed system such as a plug or not. My gut feeling is, if I had to create a hypothesis, that I think there may be some evidence that's better off maybe removing it. But again, this is my opinion based on just looking at various literatures but knowing of no controlled studies where they investigated that. What do you think, Blake?
You know, I guess I'm kind of right there with you. Without having the research, it's a little hard to say. Personally, I probably would pull the plug out. Well, actually, what I would do is, you know, not have used it in the first place, probably, especially considering the plugless systems use a smaller drill bit. So even if you're pulling the plug out, you're still going to have a larger wound in diameter. But if we had to compare using one of those and pull the plugless out of the system there, I probably would pull the plug out. But when doing that, are you going to cause more damage by trying to get something in there to gouge it out, or are you able to easily just pop it out? I would say if it's set properly, it might be tough to pull that out without causing any additional damage. And at that point, I would leave it.
Yeah, that was going to be the next thing I was going to add, is just if you had some sort of pick system, like a pick for a little curved hook that you use in like mechanics, it could be a challenge. Yeah, to get that in there, that would be one way. But again, how easy would that be? But one of the suggestions of the advantage of a plug system possibly is you have a reservoir, so you can speed up your time for putting chemistries in. Now, I've never seen a time study back and forth whether that's the case or not, but that's one suggestion of using that system, is you've got a greater reservoir for chemical and really from a production standpoint. On the other hand, removing a plug just defeats the purpose from that perspective, perhaps if you're adding more time into it. So great question. And I don't think we gave you a definitive answer on there, but I think Blake had some advice that with an open system, perhaps you can meet the same objective without worrying about removing a sealed system.
Yeah, and to touch on the timing quick there, I mean, we have done a couple of our own internal head-to-head studies and have had comparable timing in terms of application time. So Eric, if you want to touch on that at all a little more, but.
Yeah, I think everything that you guys, both of you had indicated, I'd agree with. One of the biggest things is if it's properly set in there, in the process of taking that out, you're probably going to cause a little bit more damage. But that question actually segues well into the next one. Aren't properly seated arbor plugs supposed to be slowly grown out? The cross-section picture shown looks like the arbor plug becomes encased.
Well, in our conversations with those manufacturers, if the plugs were being pushed out of the tree, it meant that the plug was not properly set deep enough to begin with. So I would assume the plugs are going to be getting encased in a general perfect setting of the plug situation.
And that's that's my understanding also, is looking at the documentation that truly, if it is set according to the manufacturer's recommendations, it shouldn't be pushed out.
Yep, absolutely. Yeah, a properly applied one should seal over. If it is being pushed out, which I have seen a lot in different cases, that's usually tied to improperly applied plug for that. Okay, next one. Are there any injectables available for scale insects?
Yes, we do have an injectable dinotephuran. It's called Transtect Infusible. And we also actually have an injectable imidacloprid as well called Zytec 10%, which, depending on what type of scales you're looking at targeting, but the dinotephuran would be the one I would generally point to first.
Yep, I'd agree with that as well.
Blake nailed it. I have nothing better to add than that. Hey, I can answer the next question though. I think it applies to me. Did you use the same rate of emamectin in the 2 and 3 year interval? Yeah, actually it was the label rate of 10 mils per diameter inch used at injection. So you could argue actually there's less chemical that was in the tree for the 3 year interval. But from our data, and there's some evidence out there that a 3 year interval, you probably are going to get protection. And so, yeah, at the time of application, whether it was a 2 year or a 3 year interval, we used the same amount of mils per diameter inch according to the label rates. And so, yeah, so we didn't apply actually extra emamectin on the 3 year interval, which would actually be against label rates, and we didn't have any permission to do that from the EPA.
Next question. I've injected over 8,000 ash trees. I found one drill bit can easily be used on at least 60 trees. How did someone arrive at 5 trees per bit?
I guess I'm not sure exactly, the testing that was done to get to that. Really, we look a lot for those piggy tails to come out when you're doing that drilling. So I didn't point it out very well in the photo when I did my little presentation there, but that photo that I had of the drill bits, it had a little wooden pigtail coming out with it. And so when you're producing those pigtails, it means you've got a really nice, sharp, clean cut. If you're getting those pigtails broken out into more like sawdust, it's likely that that drill bit isn't sharp enough. And it doesn't mean that it's not sharp enough to drill into the tree. You can still drill into a tree with a bit that's, dulled, but it means that there's a potential that you're cauterizing that wound and causing some tyloses where you're opening up that xylem, rather than getting a really nice, sharp, clean surgical cut, if that makes sense.
Yeah, and all I can add to this is when we started our experiment, our design was to use maybe a drill bit per every 5 or 10 trees and looking at pigtails. I can tell you the person that I had implement the study kind of forgot that message and did do 60 trees with just one drill bit. And so it didn't look to have any impact on our study to begin with, but that wasn't her protocol, but that's what ended up being. So yeah, it's hard to say. I would put it this way: drill bits are inexpensive. So it's really $1 a tree if you look at a drill bit. And it's one of those client costs that I think would be something to pass on. But yeah, I totally get it's a cost deal.
Yeah, absolutely. And with that, kind of the big thing is if you're doing injections over an extended period of time, if you start noticing a decrease in uptake or for when you're doing those injections, and as Blake was indicating, that lack of that kind of pigtail coming out is more serrated with it, that might be a good indication to try switching out the drill bit and see if that helps improve the efficacy. So you can kind of use what the tree has given you to indicate the approach that you should take with that. Real quick before, and Rich and Blake, it looks like we're at right about time. I have a couple more questions. Do both of you have are both of you available to still answer a couple more questions?
Yep, definitely.
Okay, great. For everyone else, just before, because I want to be cognizant of everyone else's time, I will continue to ask some of these questions on here, but I want to thank everyone for attending. If you need to drop off now, we will go ahead and submit this talk for ISA credits, but if you want to write down the number for this, that's indicated on the screen right here. So just want to put that up quick. Okay, so the next question I have on here is, do you like lac balsam?
Yeah, I'll just give an opinion on this. I have no opinion whether they're liking or disliking it. I remember when this came out, I was a student back in the early 1990s. And, this was the greatest thing of wound dressings of all time, was the manufacturer was suggesting. It does have a high nitrogen component. And so that was one of the downsides people would suggest don't use it. It's giving extra nitrogen for decay organisms. I can just tell you the data I showed you, it seemed to have no negative effect, nor a positive effect. And so from that perspective, in the case, if you're covering a wound for oak wilt, perhaps lac balsam would be the thing to use, or shellac or polyurethane, because they didn't seem to have any extra decay or discoloration relative to the controls. So from that perspective, yeah, I think it's a good thing as a coverant. But for having any extra protection, I don't know. The data I've seen doesn't suggest that's the case.
Great.
Yeah, I would agree. When you're considering oak wilt, that's a slightly different scenario. In our case, we generally would use shellac, but I think getting coverage is probably more important than not. So, but in other scenarios, I would just leave the wounds open and let the tree do its thing.
We have a next question. It's a little late, but I was curious about possible advancements in DED treatment with an IV type system with an installed permanent tank treatment. I heard about this being a new possible treatment option. Thoughts?
I guess I've not seen said technique, so I'll have to look into that a little bit further. Right. I mean, the one concern I would have about that is with the smaller systems and smaller lines, you can put less volume in. And with Dutch elm disease, it's really, really important to get up and into that canopy and get a really good, thorough, even distribution because of those beetles feeding on the 2 to 4 inch twig crotches, which is, you know, all the way out on those tips of the canopy. So the amount and volume of water that you've got to apply is really crucial and critical there. So I guess I just, you know, would question that. Without seeing it, I can't quite answer. I'll have to look into it further.
And I can't top what Blake said. I'm not familiar with it, but everything Blake said would be my answer also.
And we do have a Dutch elm disease portion of our webinar series where we'll focus more on that stuff, on our version of our macro injections, just for those of you who are still listening and interested in that.
I can answer, I guess, the last question. Looks like it's to hi, Rich. And so the 16-inch diameter was specifically amount of time it took to do treatments. So with you know, and you look at the evidence out there with smaller size trees using basal bark applications, it just works really well, and it's quick. The number of trees we can do from a production basis, it would be something I would recommend. The reason we did imidacloprid, because I wanted to try another treatment. In this case, a soil treatment. Does it vary from the basal bark spray? And the evidence suggests they shouldn't, and that's what we found. And it was truly on the bigger trees, some of the evidence suggests it's challenging based on label rates to get enough chemical in the tree, because every time you double the diameter, you have a 4-fold increase of surface area. The same thing with biomass. So really the larger trees based on label rates, the evidence suggests it's a little more challenging with such as dinotefrin or imidacloprid to get enough product in the tree to have a relative good protection for the tree. That was simply the reason why.
Great. Okay, well, that's all the questions that we have for there. So with that, wanted to thank everyone for their time today. Thank you, Rich, and thank you, Blake, for presenting today. If you haven't, for anyone that's still in attendance right now, if you haven't already, you can sign up for any of our other upcoming webinars at rainbowecoscience.com. We have as Blake had indicated, we've got a great lineup of other PhD topics and speakers coming up. And I know that today was a little bit more focused on the microinjection aspect, but we will be focusing a little bit, delve deeper into the macro injection in future webinars for this. There's going to be a survey that follows this webinar. Please take a few minutes to fill out here, and feedback is greatly appreciated. So with that, I want to thank everyone again for your participation. Thank you for our speakers today, and I hope that everyone has a great day.
Thanks, Eric.